All right, so let's do an example of the dot product. I have two vectors here on the screen. We have a mixed kind of representation where vector A is given in magnitude and direction form, and vector B is given in component form. So we want to take the dot product of these two vectors. Now, since one of them is in magnitude and direction form and one is in component form, there's not really an obvious choice in terms of which one of the two representations we want to use here. So let's try actually doing it both ways, and I'll just show you that you get the same answer either way. So let's start out by using the magnitude and direction representation. So by that, I mean I want to do A dot B equals magnitude of A, magnitude of B times cosine theta. So there's three pieces of information we need: magnitude of A, magnitude of B, and theta. What are those three things? Magnitude of A is obvious, right? That's given in the question. Magnitude of A is 10 meters. Now, notice theta is not necessarily 60 degrees. We're going to need to draw this in order to see where the theta is. And magnitude of B, that one is simply a matter of using Pythagorean theorem because the components are given and you get the magnitude from Pythagorean theorem. And I'm just omitting the units there, but these all have units of meters. So we do 7 squared plus 4 squared, square rooted, and we get 8.06 meters. All right, and then theta, how do we get the theta? So I need to draw this. Okay, so I'm going to draw a little coordinate axis here. Vector A points 60 degrees counterclockwise from the positive x-axis. So that's up like this, and this is 60 here. So there's my A. And now vector B, we have x is -7, y is 4. So that's going to be something like this. But I wasn't given the angle there. So now the variable theta that I'm looking for is this angle here, the angle between the two vectors. So that is not given in the question. I'm going to have some work to do to figure that out. I'm going to need to know the angle of B, first of all. So why don't we do that first? I'll draw a right triangle like this, and I'll solve for this angle here. I shouldn't call it theta. Let's call it phi. How about? Okay, so that angle, we would have tangent of that angle I just drew, phi, equals opposite over adjacent. So y component of B, that's 4, over x component of B, which is 7. In this case, you don't need to write the units because they cancel out. So 4 over 7, and then inverse tangent of that, and I got 29.7 degrees. And then if I look at the geometry of this, I should have 60 degrees plus 29.7 degrees plus theta equals 180, because those three have to add up to a straight line, because those three, if you add them together, go all the way from the plus x-axis to the minus x-axis. So we'll do 180 minus 60 minus 29.7, and we get theta equals 90.3. So actually, the angle between these two vectors is almost 90 degrees. So the dot product I can already see conceptually is going to be very, very small indeed. It's just going to be a tiny dot product. Okay? So let's see. Now we've got all the pieces of the puzzle in place. Last, I need to do the actual equation. A dot B equals magnitude of A, which is 10 meters, times magnitude of B, which is 8.06 meters, times cosine of the angle between them, 90.3. We might have a little bit of rounding error because of how small this angle is. Times 10 times 8.06. And I got negative 0.42. And the units of that would be square meters because it's meters times meters. Gives you square meters because it's the multiplication of the two vectors. Okay. So that's how you would do it in the magnitude and direction representation. Let's also try doing it in the component representation. So let me make a little bit of space for myself here. We don't need any of this anymore. So the first thing I'm going to need to do to solve it in component representation is get the components of A. Might as well leave my picture up because it's going to be the same picture again. I need to draw, oops, thought I switched to the drawing tool. Here we go. Draw a right triangle. So I'll draw that as my right triangle. This side is going to be AX. This side is going to be AY. So I'm going to have AY is 10 meters times sine of 60. And I'm going to have AX is 10 meters times cos of 60. And I think I can do these ones in my head because sine of 60 is 0.5. So that makes this 5. And cosine of 60 is, I think, 0.866. Let me just double check that. Oops, I did it backwards. Silly me. This one is 0.866. That is what I get for trying to show off. Oops, I need to multiply by 10. 8.66. And this one is 5.00 if you want to include those. All right. So now I've got all the components. Now I can use the formula here. So we're going to have, in this case, A dot B is AX BX plus AY BY. So that's going to be AX is 5 times BX is minus 7. You do include the minus signs here because the components do potentially have minus signs in them. And then we'll have plus AY is 8.66. And BY is 4. So now crunch those numbers. So we'll have 5 times 7 is 35 plus 8.66 times 4. And I got minus 0.36. But this is really only good to one significant figure because of all the rounding. So we got minus 0.4 either way. Minus 0.4 and minus 0.4 with just a difference in rounding in the second significant figure. Okay, so that's how you actually do the dot product computationally.